Okay, Pythagoras, section 19 on the Zeta revision sheet. A few things to look at. We're going to look at the converse of Pythagoras, Pythagoras in circles, this not so much, and Pythagoras in 3 dimensions. Okay, so 3 big things to watch out for in this, I'll quickly go over. Okay, let's just go to the side of the page to begin with. We should all remember, Pythagoras' theorem. So it's our a squared plus b squared is equal to c squared. And I'll try and draw a triangle that isn't rubbish. Okay, so Pythagoras' theorem works for right angle triangles. So there's my right angle in here. You'll be given the right angle most of the time. Opposite the right angle is the longest side, so that's called the hypotenuse, and that would be your C. Okay, and then the other 2 sides would be your A and your B. Doesn't matter which is which. Okay, so what this is saying is that the sum of the square of the shorter sides equals the square of the longer side. Okay, so classic triangle would be if we knew this was 3 and this was 4, work out what the longer side is. So 3 squared plus 4 squared is equal to C squared. Okay. So let's just do that as a little exercise then. So see, we said we know the 2 shorter sides. So if we said that was 3 and 4, what's the longer side? Well, the working would look something like 3 squared plus 4 squared is equal to C squared. So that's going to be 25 is equal to C squared. Therefore, the root of 25 is equal to C. At this point, what we've done is taken the square root of both sides, and therefore C is equal to 5, okay? Whatever your units are as well. So that's a Pythagoras add. So you do a Pythagoras add, you add the squares of the shorter sides when you know the shorter sides and you don't know the long side. If you were looking at knowing the long side, so I'll try a rectangle, try a triangle this time where I know the long side. I'll just keep it simple with the numbers again. So, say this time I knew this was 5 and I knew this was 4, and I wanted to work out this side. That's going to be a Pythagoras takeaway. Okay, so I'm going to say 5 squared take away 4 squared is going to be equal to x squared. But all I've done there is just rearrange this equation. Okay, because what I'm saying is I want to find one of the shorter sides. So maybe I'm trying to find this side. Okay, doesn't matter which it is; it's the same thing. So I need to rearrange to make this the subject. So I need to get rid of this. It's adding on this side, so I'm going to take it away. So 5 squared take away 4 squared, so that'll be 25 take away 16 is equal to x squared. So 9 is equal to x squared. So x is equal to 3 because I've square root both sides. Yeah. So your Pythagoras add is what we do when we don't know the long side. Pythagoras takeaway is when we know a long side, when we know the long side. Okay. So that's just a bit of basics into Pythagoras to get started. So let's go back to the main page. Let's have a look. So let's just have a look at some of the classic questions. This is our converse of Pythagoras. Okay, so this is asking us to prove if a triangle's right angled. Okay, so it's asking about whether B is due east of A. Okay, which is really what this question is asking is this a right angle triangle? Is that a right angle? Okay. So you see triangles and it's asking you to prove if something's north or south, or is this a right angle triangle? That kind of stuff. You're thinking converse of Pythagoras. Okay. So we're just going to use Pythagoras to kind of in reverse it. The first part of this question, we need to work out what this length up here is. Now we know the whole thing is 1,500 meters long, so we know this course is 1,500. We know that's 600 and 650, so that's going to be 1,250. So that's going to leave us 250 meters left, isn't it? So that's 1,250. What do I add to get to that? 250. Because that's your first step. Now the most important thing of converse of Pythagoras is that you don't write a squared or this squared plus this squared equals this squared, because we don't know that yet. Okay. So I always say it's SECC, like the down at the waterfront. Okay. So the first thing we're going to do is do a strategy. Okay, then we're going to evaluate. Then we're going to compare, and then we're going to have a conclusion. Okay, that's the most important thing about this. Okay? So we're using the a squared plus b squared equals c squared, but we need to lay out certainly. Okay, so our strategy is this little dotted line down the middle. Very separately, we're going to do 600 squared plus 250 squared. So that's our a squared plus b squared. And then also very separately, we're going to say 650 squared. Okay, so get our calculators out. Okay, so here we've got 4, 2, 500, and it's the same on this side as well, 422,500. So that's our strategy, okay, doing the a squared plus b squared and doing c squared, okay. So to evaluate that, we would then say, well, yeah, absolutely, 600 squared plus 250 squared is equal to 650 squared, okay. If it wasn't equal, we would say does not equal, put a line through the equal sign. But in this case, it does equal. Okay. So yeah, strategy, evaluate, compare, and now we just write a conclusion. We would say, hence, the triangle is right angled. In this case, you might then add also, therefore, B is due east of A. If you want to be very fancy, you could also write, instead of hence, you could say, by the converse of Pythagoras. Pythagoras' theorem. Apologies for the bad writing, okay? But by the converse of Pythagoras' theorem, the triangle is right angled, therefore B is due east of A. Okay? But the most important thing here is that we do not write a squared plus b squared and c squared. We have to have our strategy, which is to work out a squared and b squared independently of c squared. Okay, so for this one, think SECC, strategy, evaluate, compare, and then conclusion. Okay, SECC. I think these questions are great. Really tricky questions, really get you thinking, okay? This is Pythagoras inside a circle. The minute you see any kind of shape like a circle where something's cut off, you're thinking Pythagoras, okay? So what they want us to do is to find a right angle within, oh, that's not going to work out very well, is to find a right angle within the circle, okay? Imagine that was a straight line. Imagine this was a straight line. What I've done here is I've drawn on 3 radii, okay? They are all the same length, yeah? Because they go from the centre to the edge of the circle. So they are all radii. They're all the same length. Now we know the radius is 13. Okay, so that's how long those radii are. We know the chord length is 20, that's already on there, and we're calculating the width of the shape. So you can see from what I've drawn here, the width of this shape is going to be this radius plus this length in here. Okay? Oops. Malfunctions. So, one of those moments. So all I need to do now is to redraw this triangle with the information I've got and work out this green line. Okay, so I'll just do that off the page over here. In fact, I'll just scroll down. So let's draw that triangle. Okay, so the radius we know is 13. I'm trying to calculate my green line. Again, apologies for the squiggly lines. And this line here, I'll do this in a different, I'll do this in black. We can work out this line because that line in there is half of 20. If this whole thing is 20, then that's going to be 10. Okay? And then we can work out, do some green, we can work out x. I do promise my writing in real life is better than this. Okay? So let's do Pythagoras to work out that. That's our right angle. So we know alongside, so it's going to be a takeaway. It's going to be 13 squared, take away 10 squared is going to be equal to x squared. I could show my working, but okay, I will show my working. So if I do that, that's going to be 69 is equal to x squared. So then the root of 69 is going to be equal to x. So x is going to be equal to 8.3. Okay, in this case, it's in centimeters. That is the length of this green section. We need the width of the whole section. So the last thing I'm going to do is add on a radius to that. So then I need to add on 13 to 8.3 just to work out the full length of the shape. Right? So say 8.3 plus 13 is going to give me 21.3. So the width is equal to r plus 8.3, which is equal to 21.3 centimeters. So there's kind of 3 steps to this. And again, I do apologise for my writing. My writing will definitely improve. There's drawing your shape out and identifying the right angle triangle, which we've redrawn down here. You're then solving for one part of this triangle. In this case, we're working out this section here. And then you add on whatever else you need to do to work out the full part of the question. Okay, so get your shape, work out the missing bit of the shape, and then do the finishing step. Simple.